Hello everyone, this is part 2 of Notes 1-1, Relations and Functions. And in this lesson you're going to learn function notation. Okay, so f of x means the same thing as y equals. Using f of x just shows that the equation represents a function. So since the equation y equals 2x plus 3 is a function, we can instead use f of x equals 2x plus 3. Okay, so to find f of negative 1, we substitute negative 1 into the equation whatever we see in x. So here we would say f of negative 1 is 2 times negative 1 plus 3. Okay, so let's see how this works on the following examples. So examples, if f of x equals x squared plus 4x and g of x equals 5 minus 3x, find the following. So what I need to do here is they're giving me the coordinate for x and they want me to find the coordinate for y. So once I'm finished, I should have the x coordinate that I'm given, and I should be able to find the y coordinate. Okay, so let's see how this, let's get started with this example. So I'm just going to copy this f of negative 1/3 equals, so whatever I see in x, I'm going to substitute that x with a negative 1/3. So negative 1/3 squared plus 4 times negative 1/3. So this is all you have to do. Now I'm going to evaluate. Okay, so then don't forget that negative 1/3 squared means you're going to multiply negative 1/3 times negative 1/3. That's what happens when you have a square, and we know that negative times negative is going to be a positive, and 1 times 1 is 1, and 3 times 3 is 9. So then f of negative 1/3 equals, this is 1/9, and then this is going to turn into a negative, right? So minus, and I'm going to write a 1 just to help you see it here. 4 times 1 is going to be 4, and then 1 times 3, that's going to be 3. Now, this is why I gave you a review on how to find common denominators on one of the lessons last week, because we can see that the LCD in this case is going to be 9. So that means we are going to need to multiply this fraction by 3/3. Okay, and once we do that, we end up with a 9 in the denominator, so that gives us the same denominator, so we can proceed after that. So f of negative 1/3 equals 1/9 minus 4 times 3, that's 12, and 3 times 3, that's 9. And now the answer to this one is f of negative 1/3 equals 1 minus 12 is 11, and it's going to be negative, so this is 11/9. So the answer to this problem is the x value that I'm given, okay, 1/3, negative 1/3, and the y value that I found by substituting for x in the function, so negative 11/9. And this is the answer to that problem. Okay, so let's move on to the next example. So this is for g of x, so g of 7/12. So g of 7/12. So that's this function, so it's going to be 5 minus, I have a 3 in front of the x, so 3, and instead of x, inside of the parentheses, it's going to be 7/12. Okay, and again, I'm going to write a 1 under this 3, and then, so this would be 3 goes into 12 4 times, so this becomes a 4, and this becomes a 1. Okay, so then g of 7/12 is equal to 5 minus 1 times 7 is going to be 7, and 1 times 4 is going to be 4. Okay, so 7/4. Now again, I have a 4 on this one, but I don't have a 4 on this one. I have a 1. So I need to multiply this one, and I didn't leave myself enough space here, but I'm going to try to squeeze it in. I got to multiply by 4/4. And when we do that, we end up with the following. So g of 7/12 equals 4 times 5, that's going to be 20. 4 times 1, that's the 4, which we wanted. And then minus 7/4. And then we just combine the numerators. So g of 7/12 is equal to 20 minus 7. That is 13. And so the answer is 13/4. And last, we write the pair of coordinates. So x is 7/12, which is what we were given, and y is 13/4, which is what we found. So don't forget, this is a an order pair. So they just give you the X value, you got to find the Y value. The last example, I'm going to let you do the last example, okay? And if you have questions on how to do it, you can always send me a message and I'll get back to you with the answer. But I want you to try this one so you get some practice. So let's go on to the next section of the notes. And this is going to be the fun stuff, okay? Very interesting here, because you'll see some things that you haven't seen in a while. So what I did is I just drew these lines here, okay? And I'm going to explain to you what we are going to do in these three examples. So domain and range of continuous graphs. There's a difference between discrete graphs and continuous graphs. Discrete graph is, for example, you just see a bunch of points or many points plotted on a graph, but they're not connected. Continuous just means the 2 points are connected, okay? So this could be considered a segment. So when it comes to set, okay, so this is what's important here. Set uses inequalities with one extra step. The extra step is it uses braces, which is what these are, and they look funny, but they're curly braces, and never plus or minus infinity. So keep in mind, this is very important, okay? Plus or minus infinity, we never use that for set notation. Interval notation, on the other hand, so this one here, okay, only uses numbers or values and plus or minus infinity with parentheses and brackets. So when we use parentheses, it's because we see an open circle on the graph, we see an arrow, which means it's going to continue going in the direction the arrow is pointing, or you see a dashed line, okay? Brackets, we use brackets when we see a closed circle. That means that value is being used, okay? Or we see a solid line. So you'll see how this works in the next three examples. So let's get started with the example here. So let's pay attention to this graph. We see that the shaded region goes from -2 to 4. Okay, so it doesn't go beyond 4, it stops right there. And also notice that this circle is closed, but this one is open. So I'm going to use inequalities, which is what you have seen in Algebra 1. So I'm going to have, I'm going to use G as my variable here. Okay, I could have used any other variable, but I've chosen G because I love G. Who knows why? Okay, so G, and then we have -2 on the left and 4 on the right. Okay, so notice that -2 is an open circle, but 4 is a closed circle, so that means we can say that this one is equal to. So this is what you've seen now. I'm going to add the new, okay? I'm going to add a brace here, okay? And then I'm going to add something else. I'm going to say G such that, this is how you read this, G such that -2 is less than G, which is less than or equal to 4. So this is set builder notation, and this represents all of the numbers between -2 and +4. And again, open circle means less than, closed circle means less than or equal to. Okay, so let's go to the next problem. So on this one here, notice that we have again G. So we have G, but in this case, the circle is closed and it goes to the right to positive infinity, which is, this is the symbol for positive infinity, so it's going to positive infinity. The question is, how do we write this in as an inequality? And since it's going from 3 to the right, that means this has to be greater than, okay, not less than, because it's not going left, it's going to the right. So greater than or equal to, because it's a closed circle, 3. Now here comes a new part for this one again. So I'm going to use that brace, okay, and then I'm going to state the variable that I'm using, G, such that G is greater than or equal to 3, and then close the brace, the braces here. All right, let's go to the last example here. So for this one, it's saying from -infinity to positive infinity. So how do we do this one here if we can't use plus or minus infinity? Well, this is a special case. So what you do here is you're still going to have this, and you still have G, okay, but now I'm going to introduce something that I don't think you've seen. And this looks like an E, but it's actually the epsilon Greek letter, okay? This just says G is an element of, what is G an element of? If this goes to positive and negative infinity, that means It's an element of all the real numbers. So all the numbers you can think of, positives, negatives, fractions, decimals, square roots, and other numbers that you're going to learn in this course. Now, so this is for set notation. Now for interval notation, again, we see that it goes from -2 and to +4. But negative 2 is open, so if you have an open circle, you use a parentheses. 4 is closed, so if this is closed, then we use a bracket. Okay, so on this one we have a bracket, and then on this one here, we see that this is a closed circle, so we know it's going to be 3 for now. And it goes on to the right, it's not going to stop, so this will be positive infinity. Okay, so for this one, it gets a bracket because of the closed circle. And on this one, remember I said if it's an arrow, use a parenthesis. Okay, the next one, for this one, interval, you actually use negative infinity and positive infinity. And they get, since you have arrows, okay, you're going to use parentheses. So for key here is for infinities, negative or positive infinity. In interval, you always use parentheses, okay? All right, so let's move on to the last example on this video. Okay, and this is a word problem. So example, use set builder, okay, which is this, and interval notation, which is this, to describe the domain and range of the scenario. So don't forget, domain is all the x values, and range is all the y values. Okay, so the problem says grapes are on sale for $1.99 per pound with a limit of 3 pounds per customer. Let C of x, that's how you read this, let C of x equals 1.99x be a function that represents the cost in dollars. C of x, okay, so this will be the cost, and again, this will be your y value. If you want to write that down again, that's fine, based on the weight of grapes in pounds x. Okay, so this is going to be your independent variable, and this is your dependent variable from Algebra 1. So I'm giving you a graph here so you can see. So the cost is represented by this axis, which is the y-axis, and the weight is represented by x, which is given in pounds. Okay, so cost in dollars, weight in pounds. Now the question here is, how do we write this domain and range in the two different ways? So let's see. So let's think about the domain. Would it be possible that I could go to the store and say to myself, the grapes are on sale, but you know what? I'm not interested. So how many pounds would I buy? And the answer is 0. Okay, notice that I'm using a bracket here because it's possible that I'm going and I'm not going to buy anything. So we do use 0 in this case. And what's the greatest amount or the greatest number of pounds that I can buy? 3. Okay, and can I buy more than 3? No. So that means this one also gets a bracket. All right, so what about, before I continue with this, let me just remind you, okay, don't forget, remember I said 0 and 3? Okay, the order is always from least to greatest. Okay, that's very important. All right, so having said that, so in set, since I have these two values, again, I'm going to first open the brace, okay, and then I'm using x, okay, for the domain, so it's going to be x such that, okay, so the lowest value is going to be 0, okay, and it's going to be less than, since it's equal, since it's going to be included, because there's a chance that I might go and not buy any grapes, equal to x, and then we have the other restriction, which is 3, and it's also equal to. Okay, so this is what the domain would look like in interval and set notation. All right, so next let's do the range. Don't forget, range is your y value. Okay, so it's going to be the cost in dollars. So again, if I go to the store and even though they have this sale and I'm not interested in buying, how much am I going to pay for those grapes? The answer is 0. Okay, so I can go and not pay anything because I'm not buying any grapes. But the next question is, what's the most I'm going to pay? And for that, we're going to use that function. So when x is 3, meaning when we buy 3 pounds, when I buy 3 pounds, how much am I going to have to pay? So the answer is C of 3 equals 1.99 times 3, and this is equal to $5.97. So the other value here for the range is $5.97, and it gets a bracket too, so I'm not going to pay any more than this for 3 pounds. Okay. All right, so next question is how would I write that same thing but in set notation? So again, I'm going to use the brace, open brace, and now I'm going to have y instead of x, because this is the range, y, such that on the left hand side I'm going to have 0, again from least to greatest on this one, and also on this one 0 is less than or equal to y, which is less than or equal to the maximum I'm going to pay, $5.97. All right, so this concludes this lesson. I hope I hope you understand what you're supposed to do on these problems. Again, if you have any questions, please do not hesitate to get in touch with me. Either send me an email, send me a text message. I don't mind if you guys ask me a lot of questions. I want you to, okay? That way I can help you as best as I can. All right, I'll see you in the next video. Bye-bye.